Geoscape is a dataset from PSMA that provides detailed information about buildings and their features at a national coverage for Australia. And this is based upon high-resolution satellite imagery that PSMA acquires from Digital Globe, but also incorporates linkages to the other PSMA datasets that you probably already use, like GNAF and CAD-LITE. And the dataset is going to be regularly maintained to match the ever-changing built environment that it's attempting to mirror. I was blown away by some of the attributes that are within this dataset. So, as you expect, there's things like the building outlines, the heights of the building above ground, and then the elevation of the base of the building above sea level, the detected roof material, if the building has solar panels, if there's a swimming pool adjacent to the building, what zone is it in, and the residential indicator, those linkages to the GNAF and the CAD-LITE datasets, and also tree coverages and their heights. So here in ArcGIS Pro, we've got the building footprints, simple enough, and then the underlying cadastral boundaries from CAD-LITE that those buildings sit within. And we can use that building height to just do a simple extrusion, and we can even symbolize it to sort of get a better understanding of the kind of distribution of heights across our study area. There's also attributes for joining to the mesh blocks, so you can sort of symbolize on that to see how they're broken up at the building level. They've detected which buildings have an adjacent swimming pool, so this could be useful for fire agencies, perhaps in rural areas, or perhaps councils that need to identify houses to check for pool safety. We've also detected if the building has solar panels on top of it. So what I thought is, as the dataset starts to update over time, or get those regular updates over time, it's going to be really interesting to see the rate of growth or decline for solar in a particular region. I'd imagine if you're electric utility provider, that could be very useful information to understand and aggregate back to the postcode level. Buildings have also been classified based upon known spectral signatures for various types of roof material. There's also a zone code attribute which gives a general indication of the planning zone for a building. The majority in this scene are residential, with some rural in the foreground there, and you can also see some commercial and industrial off in the distance there as well. That linkage to the GNAF dataset, that's going to support the usage of both Geoscape and GNAF together. You'll be able to search for addresses and then return the actual building or the CAD-LITE parcel that's returned. And of course that works in the opposite way as well for reverse geocoding, so you can quickly understand what addresses are at this particular building. So here we have the buildings. I've already kind of pre-processed this to symbolize them based upon accessibility to transit stops. The lighter blue meaning essentially less walking time to those transit stops. And here in Parramatta, there's also a proposed new light railway that will increase the accessibility for a number of buildings in that area, and I'd imagine the house price as well. So what I want to show here is within ArcGIS Pro, it's very easy to create these animations in 3D, which can be quite useful to serve up as products, visualization products to people to sort of understand, in this case, a light railway and what sort of impact it's going to have on accessibility. So those that are familiar with any sort of video editing type software, very similar experience. You have a timeline at the bottom there and you create keyframes. So you kind of get the camera angle into a certain position you want to start with, create a keyframe, move it to another position, create another keyframe, maybe turn a couple of layers on or off, create a keyframe, change the time extent, create a keyframe, and keep sort of panning around. You spend a lot more time than what I'm showing here to actually come up with your real nice animation. You can also set transitions between each of the keyframes to make sure, is it go sort of directly there, or does it kind of smoothly transition around? You can then play and preview what that animation looks like from within the ArcGIS Pro interface. And then once you're happy with the final result, watermark your company logos like we've done here, and then you can export to a variety of common formats, be it straight to social media style, the correct aspect ratio and resolutions, or to an MP4, 1080, or whatever you need to do. Very quick and easy. There's also a number of interactive visibility tools, which are really powerful and quite a lot of fun to work with as well. So here we're looking at the view shed from a particular point on top of a building. Maybe you're telco and you're putting a tower, a cell tower on top of one of these buildings. You want to understand, well, what sort of range has this got, and what sort of buildings would be impacting the radio strength of this location. And it's very quick to sort of interact with that within the actual scene itself using the mouse and sort of moving things around. Now I wanted an excuse to play around with the Skyline tools that are available in ArcGIS Pro, so it wasn't really a problem, but I just wanted to work out if you could see the sea from the top of the Melbourne Star. So from the visibility tool set, there's a range of tools performing various types of visibility analysis, ranging from constructing shadow models and sight lines to the generation of view sheds, and in this case, skylines. Now this Skylines tool will create a polygon or a polyline that will show what features will actually be blocking the view, in this case from the top of the Melbourne Star in a 360 panorama. And I can actually serve these results up to either ArcGIS Enterprise or ArcGIS Online so that others can actually interact with the final results. So all I need to do is from the Share tab, give it a meaningful name and add some descriptions and tags to it so that people can easily find it and share it. And in this case I'm sharing to ArcGIS Enterprise, which is a box sitting on a Sydney, the Amazon Web Services Sydney region. So it'll actually package up the data that's sitting on my machine and zip it up to this other machine and unpackage it at that end and create these web services. And then from there, I can jump over to the browser and actually visualize what it looks like from a browser-based viewer. And this is the scene viewer where I can see that same data that's been pushed across. All those bookmarks at the bottom there are actually what I set up in ArcGIS Pro, and they've just been ported across as well. I can play around with things like the shadow settings or turn layers on or off, or maybe add another layer in. I can create those slides are basically what the bookmarks kind of translate into. But I can take it further. So this is kind of an interactive scene viewer. Maybe I just want to wrap this final result into a very simple web application that I want to share with my boss or the general public or whoever. I can then, this is a very simple web application that allows someone to browse through those bookmarks. So here, from the top of the tower, I can see the city, and I can also see the sea. I can just about see the Spirit of Tasmania there, just between those two buildings in the distance. Of course, I can just use the mouse to pan around this scene as well. But really I want to see the results of those Skyline tools that I ran. So looking at this from up above, I can see, well look, from the Melbourne Star, I've got a pretty good view of the surrounding horizon. There was a few sort of buildings that obstructed the view. But then I also took the development activity data from the City of Melbourne, their great open data portal, and I wanted to run the Skyline tools again to see, well, what's the difference if all of those developments were approved but also built as well. And you actually see like the difference in view. I'd actually see less of the sea if all of those buildings were built. And you know, in Pro I could have even calculated the exact kind of volume difference or the exact angles that would have been impacted for me. You can provide your web users more than just visualizing results. Here we can actually allow them to create their own viewshed calculations from a browser using a combination of the elevation data and that Geoscape data to see, well, from this particular location, where can I see? Maybe this is for an incident that happened. Where are the potential places that could have seen that incident? You can imagine how that could be useful for security agencies or even defence. This isn't Geoscape data, it's City of London, and these blue points here are along the River Thames and are the path of where the yacht race or the boat race is going to be. And that's just an aggregated grid of the various building heights that are in that area. And we can see we've done some line of sight analysis here to try and understand, well, where's the best kind of vantage point to see the boat race, or this might be useful for sort of monitoring the spectators that will be watching the boat race, to understand bottlenecks and things like that. The exact same approach could be applied to Geoscape data and served up again into a web application such as this. This is just one of the default web applications you can use. This is another web application. This is using the Geoscape data. This is Sydney Road up in Brunswick in Melbourne. And we can quickly kind of change the symbology to the zoning information and sort of use that pie chart to filter down, well, where is the commercial or where is the industrial, but then also look at the size of those buildings and work out, well, can I filter it down just to the ones that are, what is this? This is filter the ones that are residential and bigger than a certain size, and you can sort of understand, well, maybe this would be useful for urban planning perhaps. As part of the Geoscape product, there's also a raster layer that they give you, which is of the surface cover, served up as an image service here, and again consumed in a web app, and just allowing someone to sort of move the mouse around and understand within this 100-meter radius what is the breakdown of the underlying surface cover with the pie chart there. There's a number of web application templates that are available from Esri that would work fine with the Geoscape data as well and help you share some of your analysis results. So here is the visibility assessment. You can create these results in ArcGIS Pro and serve them up to web applications. This one, could be a CCTV camera. I'm trying to work out where can it see on the ground. There's a range of, within ArcGIS Pro, there's a range of solar radiation tools to sort of understand the potential solar radiation potential for buildings, for example. And again, we can serve these up as results, as web services. So here we can actually calculate on top of these roofs what is the solar radiation potential, and even working out where is the best position on a roof to put these solar panels. And this would be configured using a combination of Geoscape data, but also some of the climate data from Bureau of Net as well. These are all supported application templates, and with some configuration will work fine with the Geoscape data. There's a visibility assessment one. There's a 3D public survey, which kind of allows you to, doesn't have to be to the public, it can be internal, but allows people to actually kind of add comments in a geotagged kind of fashion so that you can sort of get feedback about maybe a new development that you have. Visualizing proposed developments, so that's where you sort of have a web app and you've got maybe just Geoscape data, but then also you've got a new proposed development and maybe you slide it back and forth to see, well, what's the difference before and after this development. There's another one for sharing your shadow impact analysis results. Back in Pro, this is some analysis I did with some noise modeling, so performing a noise map using the traffic, using some of the Vic Roads traffic data and the Geoscape data and some elevation data to understand, well, which sort of houses would be impacted from the noise. Didn't take into account acoustic barriers because I just didn't get the data set in time, but a good example of how Geoscape data can be used. Another example would be for, again, radio engineers at a telco, sort of trying to understand, here's all our wireless network, and what is the impact of the buildings on the signal strength from these towers. Now, with all of those attributes that are available in the Geoscape data, like everything I've shown so far has been fairly simple looking, just kind of extruded based upon the height. But with those attributes, within our City Engine product, you can actually use them to have these procedural type rules to actually texture the Geoscape, to actually make it look a little bit more realistic to what it might look like in real life. So in this instance, you could say, let's take that material type of the roof and feed that in to actually change what the roof looks like and the maximum height of the roof. And this is actually some of the Geoscape data over in ACT visualized in the City Engine product. AI, I'm sure you've been hearing a lot about augmented reality, AR, sorry. Again, this is the ACT data visualized from one of our prototype apps for augmented reality. So as you kind of pan your iPad around, and you'd be able to see the Geoscape data, but also maybe your underlying utility network underneath the ground as well. This was more, I guess, just to wrap up some fun I was having with the Geoscape data. So I won't go into the detail of how, but using a combination of the Geoscape building footprints and a combination of tweets from Twitter that were collected, I sort of did a query to understand over time the number of tweets within each building, and then use that to visualize the height value and the color, actually the total count of tweets that were happening within those buildings during this time period. This was done with query layers and using some of the magic from SQL to sort of make that happen. Nothing revelationary here. People like to tweet at stations was pretty much the end result of that analysis, if you can call it analysis. So hopefully that gave you a good understanding of the Geoscape dataset. It's a very powerful dataset. Please reach out to us or check out the PSMA website or Map Data Services, who can actually perhaps set you up for trial for using some of the data.